Chapter 1: Introduction to Docker. Docker is a tool that simplifies the process of creating, deploying, and running applications by using containers. Think of containers as a lightweight and more efficient alternative to traditional virtual machines. While virtual machines run a full-blown operating system on top of a hypervisor, containers run directly on the host operating system's kernel. This makes them faster to start, more portable, and allows you to run more of them on a single machine. Docker is designed to make your development lifecycle more efficient. It ensures that the environment your application runs in during development is identical to the one in production, which helps eliminate the "it worked on my machine" problem. The main components of Docker are Docker Engine, Docker Images, Docker Containers, Docker Registries. The main components of Docker are Docker Engine. This is the core of Docker, consisting of a server, the daemon, and a client, the command line interface. The client is what you interact with, and it sends instructions to the server, which does all the heavy lifting of building and running containers. Docker Images. These are the blueprints for your containers. They are layered, read-only templates that contain everything needed to run your application, such as the code, a runtime, libraries, and environment variables. Docker Containers. These are the running instances of your images. You can start, stop, move, and delete them. Docker Registries. This is where Docker images are stored. The most well-known public registry is Docker Hub, but you can also run your own private registry. Docker encourages a microservices architecture, where each container is responsible for a single part of your application. This makes your application easier to scale, debug, and manage. Chapter 2: Installing Docker. To get started with Docker, you'll need a 64-bit computer running a modern Linux kernel. Version 3.10 is recommended. Docker can be installed on various operating systems. Linux. Docker provides official packages for popular distributions like Ubuntu, Debian, CentOS, and Fedora. The installation process typically involves adding Docker's official repository and then using your system's package manager to install the Docker-C Community Edition package. Mac OS and Windows. For Mac and Windows users, Docker provides dedicated applications, Docker for Mac and Docker for Windows. These tools install a lightweight virtual machine that runs the Docker daemon while the Docker client runs natively on your machine. This setup provides a seamless Docker experience on non-Linux systems. The book provides detailed step-by-step instructions for each of these platforms. After installation, you can run the Docker info command to verify that everything is working correctly. Chapter 3: Getting started with Docker. Once Docker is installed, you can start working with containers. This chapter walks you through the fundamental commands for managing the lifecycle of a container. Running your first container. You can launch a container using the Docker run command. You'll specify an image to use, e.g. Ubuntu, and a command to run inside it, e.g. /bin bash. If the image isn't available locally, Docker will automatically download it from Docker Hub. Interactive versus daemonized containers. You can run containers interactively, where you have a shell inside the container, or as a daemonized process that runs in the background, which is ideal for services like web services. Managing containers. Docker PS lists all currently running containers. Add the -A flag to see all containers, including stopped ones. Docker Start and Docker Stop. Start and stop existing containers. Docker Logs. View the output logs of a container. Docker Exec. Run a command inside an already running container. Docker Inspect. Get detailed information about a container, including its IP address and configuration. Docker RM. Delete a container. Chapter 4: Working with Docker Images and Repositories. Docker images are the foundation of containers. This chapter delves into what they are and how to create and manage them. An image is composed of a series of read-only layers. When you run a container from an image, Docker adds a writable layer on top. Any changes made to the running container, like writing new files, are stored in this writable layer. This layered approach, known as copy on write, is what makes images efficient and fast to build. There are two primary ways to create your own images. 1. Docker commit. You can make changes to a running container and then commit those changes to a new image. This method is quick and easy, but is not the recommended approach because it's not easily reproducible or version controlled. 2. Docker file. This is the preferred method. A Docker file is a text file that contains a set of instructions for building an image. You specify a base image and then add instructions to install software, copy files, and configure the environment. You then use the Docker build command to create the image from the Docker file. Key Docker file instructions include: from specifies the base image, run executes a command, add and copy, add files and directories to the image, cmd and entry point, define the default command to run when a container starts, expose, informs Docker that the container listens on a specific network port, volume, creates a mount point for external data. Once you've built your images, you can share them by pushing them to a registry like Docker Hub. Chapter 5. Testing with Docker. Docker is an excellent tool for creating consistent and isolated testing environments. This chapter provides practical examples of how to integrate Docker into your testing workflow. Local development. You can use Docker to run a development environment that mirrors your production setup. For example, you can run a web server in a container and mount your local source code into it as a volume. This allows you to edit your code on your machine and see the changes reflected live in the container, all while testing in an environment that is identical to production. Multi-container applications. For more complex applications, you can use Docker networking to connect multiple containers. For instance, you can have a web application running in one container and a database in another, with the two communicating over a dedicated Docker network. Continuous integration, CI. Docker can be integrated into CI/CD pipelines with tools like Jenkins. You can create a Jenkins job that builds a Docker image with all the necessary dependencies, runs your tests inside a container created from that image, and then tears down the container. This makes your testing process fast, clean, and reproducible. The chapter demonstrates how to set up both single-platform and multi-platform matrix builds with Jenkins and Docker. Chapter 6. Building services with Docker. This chapter focuses on using Docker to run production services. It builds on the concepts from previous chapters to create more complex multi-container applications. The chapter walks through two main examples. 1. A Jekyll-based website service. This example demonstrates a two-stage process. The first image builds a Jekyll site from source code, and the second image, running an Apache web server, serves the compiled site. The key here is the use of Docker volumes to share the compiled website between the build container and the web server container. This allows you to update the site by simply rerunning the build container without needing to touch the running web server. 2. A Java application server. This example shows how to create a pipeline for deploying a Java application. One container fetches a .war file and stores it in a volume. Another container, running a Tomcat server, then runs the application from that volume. The chapter also introduces a simple web application, tprov, to demonstrate how you could automate the provisioning of these Tomcat applications. A more advanced example of a multi-container application stack is also presented, featuring a Node.js application with a Redis backend. This demonstrates how to combine Docker networking and volumes to manage a full application stack with logging and backups. Chapter 7. Docker Orchestration and Service Discovery. As you start running more containers, especially across multiple hosts, you'll need tools to manage them. This is where orchestration and service discovery come in. Docker Compose. This tool simplifies the management of multi-container applications. You define all the services that make up your application, e.g. a web server, a database, a caching layer, in a single Docker compose.yaml file. With a single command, Docker Compose Up, you can start, stop, and manage your entire application stack. Console for service discovery. When you have distributed applications, the different components need a way to find and communicate with each other. Console is a tool that provides service discovery, allowing containers to register themselves and discover other services. It provides both a DNS and an HTTP API for querying service information. The chapter shows how to run a distributed console cluster in Docker and register services with it. Docker Swarm for clustering. Docker Swarm is Docker's native clustering solution. It turns a pool of Docker hosts into a single virtual Docker host. This allows you to deploy and manage containers at a cluster level using the standard Docker API. A swarm is made up of manager nodes, which handle the orchestration, and worker nodes, which run the containers, tasks. The chapter also briefly mentions other orchestration tools like Kubernetes, Apache Mesos, and Helios. Chapter 8. Using the Docker API. While the Docker command line interface is powerful, for automation and integration, you'll want to use the Docker API. Docker exposes a RESTful API that allows you to programmatically control the Docker daemon. To use the API remotely, you need to configure the Docker daemon to listen on a network interface instead of the default Unix socket. This chapter explains how to do this and how to secure the API connection using TLS certificates. The chapter walks you through creating your own certificate authority, CA, generating server and client certificates and keys, configuring the Docker daemon and client to use TLS for secure, authenticated communication. It also demonstrates how to interact with the API using curl and how to use client libraries, in this case for Ruby, to build applications that integrate with Docker. Chapter 9. Getting help and extending Docker. Docker has a large and active open source community. This final chapter provides guidance on how to get help and how to contribute to the Docker project. Getting help. The primary places to find help are the Docker forums, the #Docker and #DockerDev IRC channels on Freenode, and by reporting issues on GitHub. The chapter emphasizes the importance of providing detailed information when reporting bugs. Contributing to Docker. If you want to contribute to Docker, you'll need to set up a development environment. The chapter explains how to build the Docker development environment, which itself is a Docker container, run the test suite, and submit pull requests. It also covers the process for contributing to the documentation and the Developer Certificate of Origin, DCO, for all code contributions. That's all for this episode of Geek Capsule. We hope it gave you a fresh perspective on the world of technology. We'd love to hear your thoughts, so feel free to leave a comment or share your feedback. If you enjoyed the show, don't forget to subscribe and join us next time for another essential read. Until then, keep your curiosity sparked and your mind open.